Hello students, let us discuss ionic radius in detail. In the chapter Classification of Elements and Periodicity in Properties. As we have already discussed the definition for ionic radius, the ionic radius may be defined as the effective distance from the nucleus of the ion which it has an influence in the ionic bond. As the size of the ions are not same, that is positive ion and negative ions are not same. So, ionic radius can be estimated by measuring the distance between the cations and anions in ionic crystals. As the internuclear distance may be equal to the sum of the radius of the anion and the radius of the cation. As we know that the size of the cations and anions are not same, so let us discuss more about this. The study of ionic radii leads to two important generalizations. These are: first one, the radius of the positive ion, that is cation, is smaller than that of the parent atom. Second one, the radius of the negative ion, that is anion, is larger than that of the parent atom. So we need to discuss these 2 points. So first of all, discuss about cations. Let us discuss cation with the help of an example, that is sodium atom. Sodium atom having 11 electrons. From this, electrons are arranged in 3 shells. There is a single electron in the outermost shell, say that is this electron, and the sodium atom have a tendency to lose this electron in order to complete the octet. So it loses this electron. Now there is only 2 shells in the sodium. Because of the loss of electron, it develops a positive charge. Now this is called as a cation. Because we are studying about the radius, so the radius is defined as the distance from the center to the outermost shell of electron. So as we compare the size of the sodium atom with the sodium ion, in this it is clear that in the case of sodium atom there are 3 shells, and in this case there is only 2 shells. Because of the loss of the outermost electron, now the distance is calculated, that is from the center of the nucleus to the second shell of the electron. So definitely we can say that because of a loss of one electron, the distance is measured from the center to the outermost electron of the orbit, that is reduced. So the size of parent atom is greater in compared to the cation. So from this it is clear that the whole of the outermost shell of electron is removed. That is, due to the loss of electron, the whole outermost shell of electron is removed. So we can say that size of the cation is reduced, so that the cation is smaller in size. There is another reason also, that is, as in the case of sodium atom, there are 11 number of proton, 11 number of electron. In the case of sodium ion, that is a cation, there are 11 number of proton and 10 number of electron. So that means when you compare the number of electron and proton, in the case of sodium atom, these are same. That means 11 positive charges and 11 negative charges. But in the case of sodium ion, there are 11 positive charge and there are 10 negative charge. That means as positive charge are present in the nucleus, so nucleus attract the electron towards itself. So 11 positive charge is attracting 10 negative charges. So that means here stronger is the nucleus. because the greater number of positive charge, that is 11 positive charge, is present in the nucleus, so it attracts the electron, that is 10 electron, towards itself more strongly because the positive charge is greater here. So what we can say that the effective nuclear charge is greater in the case of cation. So the electrons are pulled more towards the nucleus. Because of the effective nuclear charge, we can say that there is a greater attraction of electron towards itself. So the electrons are pulled inward. So the size get reduced. So from this we can say that due to the loss of one or more electron, the effective nuclear charge increases and electrons are strongly attracted and are pulled towards the nucleus. Because of this, causes the decrease in the size. So we can say that the size of cation is smaller in compared to the parent atom because of the reason, that is the effective nuclear charge increases, therefore the electrons are strongly attracted and are pulled towards the nucleus. So when you compare the values, it is clear that the size of the sodium ion is lesser than the size of the sodium atom. So the two reasons we have discussed for the case of cation. Now let us discuss for the case of anion. Let us take an example of an atom, that is chlorine atom. Chlorine atom, atomic number 17, therefore electrons are arranged in 3 shells, that is 2 in the first shell, 8 in the second shell, and 7 electrons are there in the outermost shell. So in order to complete the octet, it have a greater tendency to accept one electron. So when it accepts an electron, the structure will be little bit like this. So here you can see one electron is added. Addition of one electron, the size of the ion that is formed, negatively charged ion, that is anion, it's increased. Since in this the electron is added in the same shell, there is no extra shells here, but still the size of the anion is greater than the parent atom. Why? Because of the addition of one extra electron, we can say that the number of electron is increased. So the number of electron in chlorine atom, that is equal to 17, and the number of electron in the chloride ion, that is 18. So when you compare the number of electron in both, you can find out the number of electron in the case of chloride ion is greater. So the number of electron is increased, so electron repulsion start. That means the negative charge will repel each other. So due to the repulsion, we can say that it will move outward because of the repulsion. So the size get increased. So let us find what is the reason for the increase in the size of the atom. That is, the addition of one or more electron would result in the increased repulsion among the electrons. As just now we have discussed, as the number of electron is increased, that means negative charges start to repel each other. So because of the repulsion, it moves outward. So we can say that the size is increased. So because of the addition of one or more electron would result in the increased repulsion among the electrons. This causes increase in the size of the ion. So we can say that the size of an ion is greater than the size of the parent atom. Let us discuss another reason. When you compare the number of electrons in this chlorine atom and chloride ion, it is in this way. there are 70 number of proton and 70 number of electron. Here 70 number of proton, 80 number of electron. That means the number of electron is greater in the case of chloride ion in compared to the chlorine atom. So in this case, the nuclear charge, when you compare the nuclear charge with respect to the electron, we can say that it is less effective in the case of chloride ion, because in compared to the positive charge, we can say that the negative charge is greater in the case of chloride ion. So we can say that the nuclear charge is less effective. So effective nuclear charge per electron is reduced and the electrons are attracted less tightly by the nucleus. So because of this reason, what we can say that as the number of electron is increased, therefore the effective nuclear charge per electron is reduced. So here the nuclear charge is less effective, that means less stronger, so we can say that there will be less attraction. So when there is a less attraction, we can say that the size will be not smaller, it will be little bit larger because there is an electron repulsion also. So the effective nuclear charge per electron is reduced and the electron are attracted less tightly by the nucleus. This causes increase in the size of the ion. So the two reasons we have discussed for the case of anion, because of this we can say that the size of the anion is greater than the size of the parent atom. Let us compare the size of cations. So when you compare the size of cations, like when you compare the size of lithium ion with the lithium, you can see that the size is reduced. Similarly, sodium ion, potassium ion, rubidium ion, when you compare with its parent atom, you can find out that the size is reduced. Similarly, beryllium ion, magnesium ion, calcium ion, strontium ion, when you compare with its parent atom, you can see that size is reduced and the values are given here. So what it is clear from that, the size of the cations are lesser than the size of its parent atom. Let us compare for the size of anions. From this, it is clear that the size of the anion with its parent atom is greater size. You can see the size is greater than the parent atom. So when you talk about the anions like oxide ion, sulfide ions and Se2 minus, Te2 minus. So in all these and similarly fluoride ion, chloride ion, bromide ion, iodide ion, in all these we can find out the size is greater than the size of its parent atom. So how we conclude this one about the size? If A is the parent atom, then let A plus is its cation and A minus is its anion. So when you compare the size here, so it will be in this order. That is, the size of anion is greater than the size of the parent atom and the size of the parent atom is greater in compared to the size of the cation. So this is all about the size of the cation and anion, which we have discussed in the case of ionic radius. So the further details will be discussed in the next video. Have a nice day.